Pythagorean theorem works for right triangles. We use Pythagorean theorem to determine is something a right triangle. Mr. McGinnis uses Pythagorean theorem to make sure that whatever table he's making or chair he's making, right, needs to have a 90-degree angle. It can't be off just a little bit, right, because then it wiggles. You cannot have things constructed that aren't quote unquote perfect, right? Because they're going to wiggle and wobble. Pythagorean theorem measures 90-degree angles, perfect corners. There are some vocabulary words we need to talk about. Parts of a right triangle. There are these things called the leg, and this word is called hypotenuse. Hypotenuse. The leg, there are two of them. There are two legs. Huh. That might be easy to remember since we have two legs also. The leg, there are two legs in a right triangle. The legs make the 90-degree angle. The legs make the 90-degree angle. The legs make the 90-degree angle. They also, if you're looking for it, you can identify them by they make the letter L. Right? So that's how you can identify the legs, because they make the letter L, but it might be backwards, so don't panic. Might face the other way. Might be upside down, might be diagonal, might be crooked. But those are the legs. The legs make the 90 degrees. The hypotenuse is the longest side. The hypotenuse is the longest side in a right triangle. It's across from the 90-degree angle. It's diagonal, it's across, it's on the other side of the 90-degree angle. It's the third side. If the legs make the letter L, that's two sides. Well, a triangle only has three sides, so the hypotenuse is the other one. But mathematically, the hypotenuse is always going to be the biggest measurement, the largest value. So let's go down here to these pictures, and we're just going to label hypotenuse, hypotenuse, no, leg, leg, hypotenuse. Legs make the 90-degree angle. Hypotenuse is the longest side. This is Molly. Yep. You're welcome. So I like to, just in the beginning, trace it so that I see the L for leg, right? So leg, leg, hypotenuse. Try the next one. Leg, leg, hypotenuse. There should be two legs, one hypotenuse. Two legs, one hypotenuse. The legs make the letter L. So remember when I said it makes the letter L, and then Destiny said, what if it might be upside down? This letter L is upside down, right? Yeah. And backwards. If I flipped it in my head, then it would be the letter L, but it makes the 90-degree angle, yes? So leg, leg, hypotenuse. Here, leg, leg, hypotenuse. The legs make the 90-degree angle. Leg, leg, hypotenuse. Leg, leg, hypotenuse.
Is that what we're doing on our homework?
Not this simple. Leg, leg, hypotenuse. Right. Identification part can be easy. Now, we're just taking it up half a notch for identification because it's not just going to be, can you name these pieces? Because most of the time in math, we're going to have a measurement, right? They're going to give us numbers to work with. So when they give us numbers, when they say like this side is 3 and this side is 4 and this side is either we have to find it or they give us this number and we say, yes, it works. So to make it, take it up just a little bit of a notch, now that we know how to identify, we're going to talk about the Pythagorean Theorem. We're going to use some math, some algebra. The Pythagorean Theorem, Alex said, hey, isn't that a squared plus b squared equals c squared? It's a formula. It's a theorem. It's going to be the same every single time. So, steps to using the Pythagorean Theorem. We're going to fill in 1, 2, 3. We substitute. We substitute. What does it mean to substitute?
Replace.
Replace. Instead of A, we're going to put something. Instead of B, we're going to put something. And instead of C, we're going to put something. We're going to substitute. We're going to put numbers in place of variables. And we're going to use a special rule. A and B are the legs. When we start out, I like to say A is the short leg and B is the medium leg. So if A is the short leg, shortest, smallest number, and B is the medium leg, the medium number, what's C? It has to be the hypotenuse, right? Because there's a leg, and a hypotenuse. C is the hypotenuse, which is the big number, the biggest number, the largest number, the greatest value. Kind of like Goldilocks and the Three Bears, right? There's a baby number, a mama number, a papa number. Right? We've got 3 values. You substitute. After you substitute, you're going to use a calculator to simplify. What does simplify mean? I mean to make it simpler, easier, right? Do you go around and say, oh my gosh, you guys, I cannot wait until I'm 4 squared years old?
Is that 16?
Yeah, that's 16. You don't go around talking in math problems. You simplify the problem. Simplify means to make it easier. In this, today, we're going to square it. Because look, a squared plus b squared, right? And c squared, you're going to square it. We're going to simplify it. No one goes around and talks in math problems. Oh man, it's almost 12 minus 1 o'clock. People don't go around and say that stuff. You simplify. You make it easier. You do the math. And then last but not least, we're going to solve. And today, it's a yes or no question. Yes, it worked. No, it didn't. Well, your Pythagorean Theorem is your explain why, right? You're going to need a calculator. Now, I'm going to tell you this. It can be done on a phone calculator. So watch. I go into my calculator, and when I turn it sideways, I have the buttons that I need. Okay? Again, if you do not have the yellow calculator available, this is the computer version of a scientific calculator. Okay? It doesn't have the fraction button. That's the bummer. But we're not really going to have fractions today. So again, when you open up your calculator app, this is called a 4-function calculator. Plus, minus, times, divide. And then if you turn it sideways, it's in here. Now, there's also a free app called Scientific Calculator. It's from Desmos. It works also. But the bummer, yeah, it's also online. The bummer of all of this is test day, you cannot use your phone. You have to use a real calculator, but this will get you through in a pinch because here's my squared button. See it? Okay. I'm using a calculator, a yellow calculator, a school calculator. All right, so here we go. Let's practice. I want to know, is this a right triangle? It looks like it. But let's mathematically see, is it? So we're using the Pythagorean Theorem, which is a squared plus b squared equals c squared. Now, because this is these are my notes, I'm writing this down. You're going to get to the point where you don't need to write it, where you're just looking for the short and the medium side and the longest side. So what's the A? What's the shortest leg? Good. 4.8 squared. Plus, what's the B? 5.5 squared. And does it equal, what's the hypotenuse? 5.6. Substitute. Everybody see how I substituted? Step 2 is to simplify. Ready? I'm going to do 4.8 squared plus 5.5 squared. Oops, that says 5.8. 5.5 squared. And then I'm going to do my hypotenuse squared. 5.6 squared. I did leg squared plus leg squared. And now I'm doing the hypotenuse squared. Are they the same number? No. Is this a right triangle? No. And I'm going to put my reasoning right here. Just because it's 53.29 does not equal 31.36. Just because these are my notes, I want to be able to see if I have a question, why. I'm not expecting this part on your homework. I'm just expecting the identification part. But you have to know how to identify. All right, let's try the next one. What's your A? 6.6 squared plus, what's your B? 11.2 squared equals, what's the C? 13, because that's the biggest side. Small, medium, big. Yes? Then I'm going to use my calculator. 6.6 squared plus 11.2 squared equals, right? And then I'm going to go over here because it should equal whatever's over here. 13 squared. Are they the same?
Yes.
Is this a right triangle?
Yes.
Oh, these ones are easy because they already tell you A, B, and C, right? Try it. You test it. I'm going to write the work, but the goal is to get to the point that you just apply it. Does 6 squared plus 9.1 squared have the same answer as 10.9 squared? So let's check. 6 squared plus 9.1 squared. 10.9 squared. Yes, that worked. And then this one, 3.3 squared plus 5.6 squared, 6.1 squared. So we are identifying, do the three measurements make a right triangle? So here's your homework. Your homework is identifying. It says shade the boxes that contain the measurements of a right triangle. Watch. Watch before you start panicking. I'm going to do this top row for you. Ready? 4 squared plus 8 squared. Yes?
Yes.
And then I do 32 squared.
So they're already in order. Yeah.
Well, let's check. Do I color this in? No, because these aren't the same number. Let's go to this one. 5 squared plus 5 squared and 25 squared.
What? Oh, 25 times 4.
25 times 2 is 50, but 25 times 25, which is what squaring is, right? So Ashley, here's your question. Can I do 23 squared plus 20 squared?
No, you have to do 12. You have to do least to greatest.
I have to do smallest, which is 12,
Oh, dang it.
plus medium, which is 20,
And then do 23.
and then 23.
So they're not even in order.
Some of them aren't in order. Some of them are. What about this one?
It's not in order. So 33 squared plus 56 squared. And then 65 squared.
So that would get colored in because it worked.
Wow, you just gave us like the answers.
I mean, I gave you 4 answers.